Today's lesson is on combinations of functions as we're getting close to wrapping up Chapter 2, Functions and Their Graphs. So our objectives today are to add, subtract, multiply, and divide functions, then find composition of functions, and then use them to model and solve problems. So the first thing we're going to talk about is our arithmetic combinations of functions, and these simply are taking functions, adding them, subtracting them, multiplying them, and dividing them to create new functions. So the domain of an arithmetic combination consists of all the real numbers that are common to the domains of f and g. But in the case of the quotient f of x divided by g of x, you have to go a step farther and look at the restriction where g of x does not equal 0, which makes perfect sense because we cannot divide by 0. So if we're going to add two functions like f plus g equals f plus g of x, means we're going to add f of x and g of x. Similarly, if we subtract, we're going to do this. Product would be f of x times g of x, and then the quotient is f of x over g of x, means the same thing. So with the domain restriction here, where g of x cannot be 0, all of the other domains for f and g apply for sum, difference, and product. So if we are given two functions, 2x minus 5 and 2 minus x, let's add them. First one's add them. So we're going to take f of x plus g of x, which gives us 2x minus 5 plus 2 minus x. Now I'm going to go ahead and put them in parentheses so we know that that's f of x and g of x. And now you just combine them, x minus 3. So if we combine those two functions, we get x minus 3. Now if we subtract them, same idea, 2x minus 5 minus 2 minus x. Well, now we have to distribute the negative sign because we're subtracting all of g of x, and that's a little different then. We get 3x minus 7. F times g is exactly what you think it is. Multiply the two functions. So this is going to be a FOIL problem. 4x minus 2x squared minus 10 plus 5x. So negative 2x squared plus 9x minus 10. And then f of x divided by g of x is simply 2x minus 5 divided by 2 minus x, where x cannot be 2. So that's just using arithmetic combinations. So now we're going to evaluate these. So for instance, f minus g of negative 1 simply means f of negative 1 minus g of negative 1. So that would be negative 1 squared plus 1 for f, and we're going to subtract x minus 4, which is negative 1 minus 4, and then we just evaluated it. See, that's minus 5, correct? So 7, 1 plus 1 plus 5. Okay, here's a product, f of 2 times g of 2. So we're going to have 2 squared plus 1 times 2 minus 4. So that's 5 times negative 2. So we end up with negative 10. Okay, if we're given x squared plus 6 and the square root of 1 minus x, we're going to find the quotient of r divided by v, and then we're going to look at its domain. So x squared plus 6 over 1 minus x would be r of v of x. So we take r divided by v And then we have to talk about its domain. Well, x has got to be bigger than, or 1 minus x has to be bigger than 0. Can't be equal to it, can it? Because we can't have 0 in the denominator. So I'm going to add x. So x is less than 1. So our domain then is negative infinity to 1. That's the only place this quotient will work, are for domains from negative infinity to 1, or x's in the domain from negative infinity to 1. Now, composition functions. These are fun. So this is when we take a function and put it in to another function. And we say f of g of x in this case. In this case, we say f circle g of x. But f circle g is the same as f of g of x. Now, the domain of this composite function is the set of all x's in G such that the range of G is in the domain of F. So in other words, the domain of the composite function is dependent on the domain of our input. Okay. So let's go ahead and use this first one. We have a parabola and a line, f of x and g of x. And we also have another line, h of x, x plus 9. So what is f circle g of x? Well, that is the same thing as f of g of x. So we're going to take g and put it in for x in f. So everywhere you see, that's minus 1 in it. Everywhere you see x, we're replacing it with negative x plus 7. And then you have to evaluate it. So you have negative x plus 7 times negative x plus 7. I'm going to go ahead and distribute the 5 if you're okay with that. And that's going to be x squared, let's see, minus 14x plus 49, I believe. Let's see, x squared minus 7x plus 49. Yep. Minus 5x plus 34. So 2x squared minus 28x plus 98 minus 5x plus 34 gives us 2x squared minus 33x plus 132. And the domain, obviously, would be negative infinity to infinity, because that's a parabola. Okay, G circle F. So now we're going to put G, or F, into G. So this is a little bit easier. So we plug negative, or 2x squared plus 5x minus 1 into our G in our x, and distribute the negative sign, and we end up with negative 2x squared minus 5x plus 8. So f of g of x is not the same as g of f of x. Composite functions. Okay, how about g of h? So h goes into g. I like to write it like that. So x plus 9 is going into our x in G. So negative x minus 9 plus 7 would be negative x minus 2. How about h of f? So f is going into h. So we're going to take f, 2x squared plus 5x minus 1, substitute it in for our x in h, and then we're going to add 9. So 2x squared plus 5x plus 8. Composite functions are fun. Okay, number 5, last one. A pebble is dropped into a calm pond, causing ripples in the form of concentric circles. Concentric means same center. The radius in feet of the outer ripple is r of t equals 0.6 t, where t is the time in seconds after the pebble strikes the water. The area of a circle is given by the function a of r equals pi r squared. Find and interpret a circle r of t. Well, that's the same thing as saying a of r of t. So we're going to put r into a. Well, here's r of t. We're going to put it in there. So it's going to be pi times 0.6 t squared, quantity squared, which will lead us to 0.36 t squared, or 0.36 pi t squared. So that would be our area after so many seconds of our pond by the ripples.